Hi guys, welcome to ramanujan.math.circle, and today we're going to be covering geometry. So without further ado, let's get into the topics. So let's talk about perimeter first. By definition, a perimeter is the length of the outer boundary of a geometric figure or shape, basically, to put it in simple terms. So there are some special kinds of perimeters. There's one with a rectangle, right? And if a rectangle is like this, and one side is W, one side is L, then the rectangle has a perimeter of 2L plus W, which is 2 times L plus W. The reason for this is because the opposite sides are the same length. So it's L plus W plus L plus W. So that's equivalent to this. For a square, which is a special rectangle, right? All sides are the same length. So we're going to call those length S. So the perimeter would be S plus S plus S plus S, right? 4 sides. That's 4S. So now we'll talk about something called min perimeter and max area properties of square shapes. And what that means is that whenever you want to minimize the perimeter and maximize the area, meaning have the greatest area and have the least perimeter, then make a square-like shape. So if you have if you want an area given an area, you want to have the least perimeter, then you try to make it square-like. And if you are given a perimeter and you want to have the maximum area, then you try to make the shape square-like. So for example, if there's a question that there's 20 meters of perimeter, and your boundary is a rectangle, then your area, for example, if it was 6 and 4 like this, 4 and 6, then the area would be 24. If it were 2, 8, for example, it would be 16. So the area 16 is less than 24. So as a result, we would have a better shot with this one. But then there's one that's better, which is 5 and 5, right? The area is 25 and the perimeter is 20. So that is a square, literally. So the more squarish, i.e. the more closer the length and the width are to each other in value, the more maximum area we get using less perimeter, the least perimeter possible. And this often comes useful when you do fencing related problems and things like that, because they ask sometimes what the maximum area given some fencing materials and things like that. We also have circles, and circles are, circles look like this, right? And they have a radius r. The circumference is 2 times pi times r. Pi, or pi in English, is equal to approximately 3.14159, so on and so forth. So a circle with a radius r has a circumference or a perimeter, right? It's a circumference is a perimeter of a circle. So that is 2 pi r. And then we have a regular n-sided polygon. So if there's n sides, right, then right, n sides, then the perimeter is n times s, right? Because each side has s length and there are n sides. So you multiply those two together and you get ns. And so yeah, and if a polygon with n sides, so regular basically means all sides same length, and all all angles are the same, right? But a polygon could have n sides, but also have like different lengths. So like A1, A2, AN, these are the side lengths. And in that case, you just sum these up to get the perimeter of this n-sided polygon. So all it is adding up the side lengths, and that's basically what perimeter is. The biggest takeaway from here is the min peri and max area for square shapes, because that is always really useful. And the way I remember it is I go min peri max area square. That's the way I remember it. So it's a really good property, and it can be used throughout. This fundamental idea can be used in various different cases. Okay, so now we're gonna be looking at an example. So I'll read the example, I'll give you some time to solve it, and then we'll come back and discuss. A region is bounded by semicircular arcs constructed on the side of a square whose sides measure 2 over pi as shown. So this is 2 over pi. What is the perimeter of this region? So like I said, we'll come back and discuss after some time.